Hello, everyone. Today I'm planning to go over graphing rational functions. So what are rational functions? Graphing rational functions. Okay. So when I say graph rational functions, the word rational comes from ratio, right? So I have a ratio of two functions, two polynomials divided by each other, and I want to plot that. So I'm going to show you a very simple methodology of how to do that one step at a time. And then we'll take examples that cover pretty much all the different possibilities that you can get. So when I say rational functions, I have, for example, f of x equals, say, g of x over h of x. So that's a polynomial. It may be like 3x squared minus 2x plus 5, and the denominator is something similar. And I want to plot that. I know how to plot each one separately. We learned that, or you should be able to do that quite easily. But when I divide them, how does that work? Okay. So we'll see how that works in a second. We are going to list like pretty much five major steps that we are going to try every problem to find, to give us some parts of the puzzle. And then we'll connect the dots to see the big picture. Okay, so think of it as a puzzle. It's like a blank page, and then I can find few points on it, and then I see how I connect these points. Okay, come easy. The idea is very, very simple. First of all, we are going to look at, as I said, at five things. Pretty much the first, it doesn't have to go through the same order, I'm just, you have to pick some order, right? So I would make something that makes sense, but you don't have to do step one before two and two before three. It's just five steps. So step number one, let's say we find horizontal or slant asymptotes. So, what's an asymptote? An asymptote is a line, most of the time it's a line, where the graph, when it approaches it, it starts to curve and goes parallel to it. Okay, make sense? So, I may have a horizontal asymptote like that. So the graph, say it's coming from high to low, and it approaches it and it goes parallel to it. Or if it's a vertical one, it does the same thing. It goes down or it goes up. We learn how to find either. And then we may have a slanted asymptote. We are going to only consider cases where the slant asymptote is a straight line. It can be more other than that, but usually in your course, we only look at slant asymptote as linear. So again, it goes like this or like that. And the graph will never cross a vertical or a slanted asymptote. It may cross a horizontal at we can make examples that let the graph crosses a horizontal one, but that's not a big deal. So we'll see how we find out that. So we are going to look at the degree of the numerator, degree of gx. Remember we said what the degree is? The degree is the highest power of x in the numerator, and the degree of h would be the highest power of x in the denominator. So we are going to look at degree of g of x over degree of h of x. If g of x is less than h of x, then f of x equals 0, which is the horizontal axis, is a horizontal asymptote. It's as simple as that. If g of x equals h of x. So in the first case, the bottom was higher than the top. Here they are equal. Then f of x equals the leading coefficient of g of x divided by the leading coefficient of h of x. What is that leading coefficient? Where did I hear this term before? Remember when we were plotting polynomials, or if you didn't watch this video, you should know that if you write a polynomial function in a decreasing order of the power of x, then the highest power, if it say x cubed was the highest power in the numerator, and the equation was 3x cubed minus something. So the 3, we call it the leading coefficient, which is the coefficient of the highest power of x, either in the numerator or the denominator. Sometimes, instead of saying the highest power of x, we refer to that as the degree. So if the leading coefficient, which is the coefficient of the degree of gx, is the same, if the degree is the same, then f of x equal the leading coefficient of the numerator over the leading coefficient of the denominator. That becomes the horizontal asymptote. Okay? And finally, if g of x is larger than h of x, so the numerator is higher than the denominator, then f of x equals the quotient of g of x over h of x. What is the quotient? Meaning I'm going to do a long division. I'm going to divide the numerator over the denominator. I don't care about the remainder at the end, but I'm going to take the value, which I said in all examples we are going to see in this course, they would be linear. So it would be a straight line going up or down depending on the slope, but that becomes a slant asymptote. So that is a slant asymptote. Oh. So you can see here, we either have horizontal or slant, or I said of. Okay, so that's the first step. It looks long, but it's really one of the three. It's just one thing. You either say x-axis is an asymptote, or x equals 3, or y equals 3, or y equals -2, f of x, I meant. Or I have a slant asymptote, f of x equals 2x minus 3, whatever. Okay, so it's just one thing. Step number 2, find the vertical asymptote. So how do I get the vertical asymptote? Basically, x equals the value that makes the denominator equal 0. Because if you divide by 0, you get infinity, positive or negative. So I have a straight line, and when it approaches, it either goes up to positive infinity or down to negative infinity from both sides. That's very easy. You just set h of x equals 0 and solve for x. Step number 3. Find if there are any holes. What's a hole? A hole in the graph is a value that when I factor both the numerator and the denominator, they get a common factor. So x equals -5, both top and bottom. It means that at x equals 5, you get 0 divided by 0, which is undefined. So that's why when x equals that value, there would be a hole in the graph. If you plot it using a calculator on the computer, you won't see it, right? Why won't you see it? Because it's just a small pixel in the whole graph. So you won't be able to see it, right? But it's this point, the graph doesn't pass through it. There is like a small discontinuity in the graph at that point. So this only happens if I can factor the numerator and the denominator and say this, I see the same factor. And then I would ignore it. So I would say, okay, there is a hole here and just ignore that. Okay. Um, okay, what else? Step number four. In step number four, we find the x-intercept. How do you find the x-intercept? Meaning when the graph crosses the x-axis. Well, when it crosses the x-axis, what is the x-axis? Y equals 0. So set, in this case, g of x equals 0 and solve for x. So that will tell you it crosses at x equals -3, at x equals 10, at x equals, or it doesn't cross the x-axis at all. Okay. And step number 5, find the y-intercept. Meaning set x equals 0 and find f of x. So now these 5 things, once I find them, I can plot the graph quite easily. Of course, you will tell me, okay, if there is a vertical asymptote and the graph is coming from the right or to the, how do I know if it's going up or down? I know there is a vertical asymptote, or I have a horizontal asymptote. Does it go to the right or to the left? So these are few things we are going to learn or to do it in an efficient way to know how the graph goes up and down. And then finally, the last step is to pick points in the middle so that you draw it more accurately. For example, if I know the graph is going like that, is it going like that or like that or like that? Where does it cross in the middle? So you pick some points like you do when you graph anything. Like you set x equals 3, find y, set x equals 4, find y, set x equals -1, find y, and it would give you a better like a more precise way of plotting that. Now, let's take one example because we had to go through the theoretical stuff. So we'll do one examples now, and then in the next session, which I will tape right after this one, but you will see, you can watch it later. We will do a couple of examples. So maybe we'll do an example where g of x is less than h of x, and then next time we'll do the other two. Okay. Uh, maybe I'll come up with an equation that shows you a hole, how you identify a hole. So let's take an example, and we call that example 1, and then we'll do 2 and 3 probably next time. Let's say my f of x equals 5x minus 10 over x squared minus 4. So what do we do in the beginning? Again, you don't, maybe I should have told you before doing any of that, factor the numerator and the denominator to make them as simple as possible. Because how can I find a hole if I don't have factors or stuff like that? I know that the degree, so I can start by saying I have a horizontal asymptote at f of x equals 0, which is the x-axis. Why? Because h of x, the degree of h of x is higher than that of g of x. And you say, should I memorize? No, you shouldn't memorize anything. All what you have to do is to say, what happens if x gets very large or very small? Meaning if x is either, say, a billion, 1 billion, or -1 billion. Notice that if x is say 1 billion, then 5x minus 10 is the same as 5x. I'm not saying, oh, it's like the numerator is 5 billion minus 10. No, it's 5 billion, right? 10 is insignificant there. But the denominator in that case would be what? 1 billion square. So 18 zeros, what? Quintillion? So now I can divide numerator and denominator by a billion, and you will get this would be 5 divided by a billion, which is almost zero. So you see, as x gets larger and larger, and even if it's negative, it doesn't matter, because if you divide anything by billion or negative billion, you will go to zero, right? So I know that's why the horizontal axis is an asymptote. And that at the very far end, maybe in some cases it can cross the x-axis, but then it will go back and become asymptote to it. It may or may not cross the x, but the vertical will never be crossed. I'm not gonna cross the vertical asymptote. Let's simplify that or factor it. I can take a factor of 5 in the numerator. 5x over 5 is x. I have a negative sign, and 10 over 5 is 2. The denominator is a difference of two squares, x squared minus 2 squared. So it's x minus 2 times x plus 2. And what do I see here? I see a hole at x equals 2. So from now on, I'm going to work as if x minus 2 doesn't exist. My equation is just 5 over x plus 2, okay? Now, so I'm going to say number 3. In our case, it's a second thing, but it's just so when you go back here, you see what I meant by there's a hole at x equals 2. Okay. Then I go back to number 2. Vertical asymptote. Notice we are assuming that x minus 2 and x minus 2 don't exist, because that's what's the hole is. So what makes the denominator now equal 0? The denominator would equal 0 if x plus 2 equals 0 or x equals negative 2. So at x equals negative 2. So let me get a graph paper just to plot what we know so far. Here's my x-axis. Here's my y-axis, or f of x. Same thing. Notice that I have a hole at x equals 2. So let's say this is x equals 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So at x equals 2, but at x equals 2, if the hole didn't exist, where should the y be? Notice that the y is now 5 divided by x plus 2. If x is 2, you get 5 over 4. So here, the hole at x over 2, and f of x equals 5 over 2 plus 2 equals 5 over 4, or 1.25. So at 2 and 1.25 here, there is a hole. I also know that x or y equals 0, the x-axis, I mean, is an asymptote. So let's do that as a dotted line. Here's a different color so you can see it clearly. And we said there is a vertical asymptote at x equals negative 2. A vertical asymptote at x equals negative 2. I have 4 areas now. I know that the graph would be here because there is a hole, so it would have passed through this point. And I may have another branch here or there. We'll see. We'll see how we find it. So Here we found the first three steps. The next step is to find the x and the y-intercept. Okay, number 4, x-intercept is where the numerator equals 0. But we said the x minus 2 is not there, right? So the equation is 5 divided by something. So how can that be equal 0? It only can equal 0 when x approaches infinity, which we said earlier. So this graph doesn't cross the x-axis. It will never cross the x-axis. So I may have a branch like this and a branch like that, or a branch like this and a branch. We'll see. We'll see. Most likely they would be these two branches, but it doesn't. There is no y-intercept, x-intercept. Last one, I find the y-intercept. Set x equals 0. So the f of x, notice again, I ignore the x minus 2. I ignore the whole. I have 5 over 0 plus 2, which is 5 halves or 2.5. So at 2.5, the graph crosses. So now I know that the graph is going to look something like that, right? I don't need to worry about, oh, is it going up or down? I already know it's going up. I knew when I saw the hole, right? I'm not going to cross the x-axis, so how can I come here? It has to go up. If I want to make it better, I see the value of x, as I told you, you take extra points. So should I do it like this or more down? So you can find, for example, at x equals 1, you get 5 over 3, which is 1.66. This is 1.5, so somewhere in here. No, I'm sorry. This is the 2. No. Yeah, this is the 2. So 1.66 would be somewhere in here, right? And the graph would look something like that, this piece. That was an easy graph, so I can plot this branch very simply. I already knew it was going up. So that's half of the graph. Okay. Now, I want to see what happens when x is less than -2, meaning I'm on the left. Is my graph going up to positive infinity or down to negative infinity? The way to do it is to say, okay, if x is slightly less than -2, so x equals to negative. Here, I mean slightly less, like -2.001, for example, or -2.005, something very close to -2, but slightly to its left. This negative meaning slightly to the left. Notice again, I'm ignoring these two guys. So it's 5 divided, or 5 is, I don't need the value. I don't care about the value. All what I'm saying is that the numerator is positive in this case, and the denominator, if that's slightly less than -2, so -2.1 plus 2 is negative, so it's negative, and positive over negative is negative. You see, I don't need the value. All what I need to know is the sign positive or negative. If it's positive, then my graph is going up. If it's negative, my graph is going down. So now I know that this graph, first of all, on the very far left, it's asymptote to the x-axis, and here it's asymptote to the negative. And that's what I was saying. If I plot it like that, should it go very close and then drop quickly, or should it go like this? And that's when you find it takes few values. If the numerator is 5, I can take this as -7. Why -7? Because -7 plus 2 is -5, and 5 over -5 is -1. I don't need a calculator. So you can make it simpler if you want. So at x equals -7, here is -5, -6, -7. I have the y is -1. So you see, this wasn't drawn properly. As x equals -3, 5 over -3 plus 2 is -1. So 5 over -1 is -5. So here I am at -5. And again, now I can plot it better. You can pick more points to make it more uh, accurate, but it's something that goes like that. And I'm done. I identified the y-intercept, 0, 2.5. I identified the whole, 2, and 5, 4, 1.25. And basically, I found two more points, like -5 and 1, and 1 and -5. And that's it. We found this as x equals -2, and here f of x equals 0. These are the two asymptotes, and you get that graph. Quickly, before I close, let's do that on a calculator. It's just one graph. We said 5x minus 10 divided by x squared minus 4. And I have to go slightly below -5. So let's do the -10 to 10. Oh, we can do it negative, well, to enlarge it a little bit, let's say to 6. And here from, again, -6. Anything higher than 3, let's say 4. Let's see how it looks like. Excellent. You can go to the table if you want, and you will see -1, -5. If you go up, you get -5, oops, and negative. Oh, no, I should have said -7. It was -7. Remember, this is -5. Yeah, this is -7. And at -7, you get -7 and -1. I wrote it 1. It's my mistake. And this one also is negative. What did we do here? We said -3. This is -3. Yeah, -3 and -5. What do we have? -3, -5. You see, -2 error because it's going to -infinity. Let's find at +2 error because there is a hole. It should have been 1.25. You can see that it's 1 and 2/3 and 1. Somewhere between 1 and 1.667, which is 1.25, there is a hole. Okay, so again, if you have a calculator, graphing calculator, of course, you will get that very quickly, but so apologize for that. I was just writing it quickly. I didn't, even though I have here -7, I don't know why I wrote it -5. It's -5 over 5, so that's why I got it. Okay, and here's -3 and -5. Okay, I hope this was clear enough. I know this was a simple one where we have like linear and then a whole, but next time we'll take two more examples that are more advanced and that should be doing it. Okay, thank you very much for your time and hope to see you soon.